Welcome back to a revisit of the Candy Bar Diet program. We worked on this program together in week 3, and then you worked on it separately as part of your homework project. Recall that this program calculates the number of candy bars a person would need to eat to maintain their body weight. The BMR is the basal metabolic rate, which is the number of calories needed for a person to maintain their weight. The formula varies based on female or male and based on age and weight and height. Given those details, we will calculate the BMR for an individual and then report to them how many candy bars they would need to consume daily to maintain their weight. This program also implements the additional functions needed for Programming Project 10 from page 178 in your book that you included in your last homework. Let's scroll down and take a look at the new main function, and then we will dig into the details of the added functions to this program. Here is our main function. The first thing we see is that we call a function called instructions. Then we retrieve the inputs needed in order to perform the task of calculating the number of calories through the BMR and the number of candy bars that the user will need to consume. So the input section uses several functions. One to get the user's name, another to get the user's height, another to get the user's weight, then to get the user's age, and to get the user's gender. The process part of the program calculates the BMR based on those inputs that we retrieved from the user for height, weight, gender, and age. Once the BMR has been calculated, we then make an adjustment to the BMR based on the activity level of the user. So we call function activity adjustment and multiply that times the BMR and then add it to the BMR for our new BMR. Based on that revised BMR, we calculate the candy bar count by dividing the BMR by our constant candy bar calories, which was 230. After we're finished the process section, we move to the output section of our program, and we call function print BMR report, passing to it the candy bar count and the individual's weight. I'm going to run the program and we'll watch the output, and then we will dig into the details of these functions. It asked for my name. Now it's asking for my height in feet and inches. I'll say that I'm 5'2". My weight and my age, I'm never telling. And gender. The program then asks me to provide an activity level. I'm going to say that I am active by selecting 2, and the program reports that I need to eat 7.38 candy bars each day in order to maintain a weight of 110 pounds. Okay, so we see that the program works just as it did before we changed this into using functions. Now the one thing to note here is the overall design. We are sticking with our input, process, output strategy of organizing our program. The overall structure of input, process, output is a good strategy. And think about the main as though it were a boss or an assembly line. Things have to happen in the proper order, and we can see the proper order by following the function calls in main. This gives us an overall picture of what the program does, but we don't see the details of how it is accomplished. The details are in each one of these functions. This is a good organizational strategy to use. Even though this program is somewhat small, programs only are going to get larger and more complex. So this gives us a good organizational strategy for when the projects get larger and more complicated. Okay, let's look into the details. I'm going to scroll up above main, and we will see the declarations for, first, any constants the program has. These are kept in what's referred to as a global scope because every part of the program below it has access and can use the CandyBar calories. So the word scope in programming parlance means the area of the program where that particular variable or constant or function is available. Notice that all of our function prototypes are declared right underneath our constant. This means that all of these functions are also available to be used or called from anywhere else in the program. They're all global. This is an important consideration of C and C++ programming. The intent of the authors of the language was that you would keep your functions small and single-purposed, and therefore every one of these functions are like peers to every other function. None of them are dependent on another function. I don't have to be inside one function to get to another function. I could get to any one of these functions by calling it by name, passing it any input parameters that it requires. Okay, let's take a look more closely. Function instructions will explain the program to the user. Notice it has a void return type. You can pretty much guess what that means. There is no return. And when we see this in code, as we see as the first line of main, it's on a line all by itself. When that function is called, all of the command lines or instructions within that function will be executed. The next function we see on line 21 is getUserName. Pretty explanatory. This part of the program, this function, will ask the user to input their name and then return that to main. The result of that will be assigned to string name, as we see on line 35. I'm going to scroll down a little more. Next is the prototype on line 22 for getUserHeight. That is used in the input section of main on line 37. Again, the details are hidden from main. It is the getUserHeight function's job to get that information from the user and return the value to the main program here, which is assigned to height. Then we see getUserWeight, getUserAge, and getUserGender. The return types from these functions will exactly match the way they're being used in the code in main. So notice that getUserGender returns a char because we stored char as either F or M to represent female or male. The next set of functions, calculate BMR and activity adjustment, both have inputs and outputs. So let's see how that is used in the process section. On line 26 we see double calculate BMR. So the return type will need to be double. The name of the function is calculate BMR. As inputs we have height, weight, the gender, and the age. Now on line 43 we see the call to calculate BMR. Once it's made the calculation, the result will be assigned to local BMR of type double. Then we adjust the BMR based on the activity adjustment. So we call that function and use the results to multiply times BMR and add to it to get the new BMR. Then on line 45, the candy bar count is calculated based on dividing the BMR by the 230 candy bar calorie count. On line 28, we see the output function print BMR report. This function will be called in the output section on line 48 in main. Print BMR report. The inputs we need for that are the candy bar count and the weight of the individual. Note the return type. It's void, which means it's not returning a value, just like our instructions did not return a value. Therefore, in the output section of our program, we see that print BMR report is on a line by itself. It's not on the left side of assignment. It's not being used in a calculation. It's a standalone function that will, given the inputs of candy bar count and weight, print out the results for the user. Lines 50 through 52 are just to hold the screen and then close the program. So let's scroll down and look at these individual function definitions. The first one are the instructions. These are pretty straightforward. Again, we see the void as a return type because this is not going to be sending any output back to the program. It just welcomes the user, tells them about the program. The next function returns type string. So this will need to have a return statement that sends back a string value. On line 63, we declare a local string variable named name. We send output to the user to ask what their name is. We collect that through the input cin, and then we return that value as output to the calling program. We see this done with getUserHeight. Now getUserHeight, we ask them to enter their height in feet and inches. We are not returning those individually. We have local variables for feet and inches declared on line 72. We read those two values in on line 74, and then we calculate the total number of inches for height and return that value to main. Again, keep in mind the return type must be an int. It has to match the return type described in the function header and the function prototype. Below this we see getUserWeight, getUserAge. These are pretty straightforward. getUserGender. Let's take a look at that because I've added some interesting code here that you may find helpful when you write programs. getUserGender returns a char. The first line of this program function declares char gender and then asks the user to enter F for female or M for male. We read the value typed in, and that next line of code on 99 is a function that will automatically make the input an uppercase. So if they type in little m, it will return uppercase M. If they type in little f, it will return capital F. And that makes the while checking simpler. I just have to look for capital F or capital M. And if they typed in little m or little f, this program will still work just fine. We always want to make it as user-friendly as possible. Okay, now if they don't type in F or M, then the loop will repeat and ask them to enter their gender, F or M. And we'll stay here until we get good input from the user of the program. Finally, when we do get F or M, we'll return that value to main, who called us. Let's look at the process functions. The calculate BMR is based on their height, weight, gender, and age. We initially set a local BMR value to 0, check for male or female, and do the calculation based on the gender. Then we return that value to the calling program. The activity adjustment asks the user to report on their habits. Now we accepted as input their name. So to make this a little more user-friendly, we initially set their activity level to character 0. Notice I'm using a char there. We'll talk about that in a minute. And we have the BMR adjust variable that will be either 0.2, 0.3, 0.4, or 0.5 based on their activity level. So initially that's set to 0. Then we print out a little menu of the possibilities for our lifestyle, very active, active, moderate, or sedentary, and ask the user to choose among those 4 options. We read that value in as a char. Now, I chose to make this a char instead of integer because no matter what they type in, it will not cause any problems in terms of crashing the program. When and if you ask them to type in an integer 1, 2, 3, or 4, and you read it in as an integer, if they mistakenly hit the W, it would crash the program. So to avoid those kinds of problems, it's always a little bit better to read input as character or string data, and then you can parse it out as needed inside the program. Alright, so let's see how we're handling that. Line 136 has a switch statement based on the activity level entered. I'm going to scroll just a little bit. Case 1 on line 138 checks for character 1. If a 1 was input, we set the BMR adjust to 0.5 or 50%, and then we break. The next line of code after the switch is return the BMR adjust. So if the user entered 1, we would set the BMR adjust to 0.5 and return that value to main. If the user selected 2, on line 139 we would match case 2, set the BMR adjust to 0.4, break takes us out of the switch, and we would return 0.4 as the value. Likewise, case 3 on line 140, case 4 on line 141. Now if they type anything else, on line 142 we have the default. We will print a message invalid entry with their name, telling them to try again. Then we call this function again. So we're going to stay here until we get either a 1, a 2, a 3, or a 4 from the user as input, because they're the valid values that we're looking for. Okay, once we do finally get good input, we return that to main. Finally, scrolling down, we see the output function. Again, this is a void function, so it stands alone on its own line of code and will be executed by printing out how many candy bars they need to eat in order to maintain their particular weight in pounds. Now, we did not include return statements in the print BMR report or the instructions. There's nothing wrong with doing that. It would not hurt the program to do so. And actually, I'm going to add one here just to demonstrate that. But note that I don't have any value to return. So the return statement will just say return. And that's why we don't necessarily have to include it. I'll scroll up and put that inside the instructions function as well. The return forces an immediate exit, but I also immediately exit when I get to the end of the function. And so I don't really have to have a return, but it doesn't hurt to put it in there. The important thing again to note is that I don't have any output value to return. Therefore, instructions and print BMR report are both void functions, and when we see them listed in the program being called on line 48 and line 32, they're just a line of code by themselves, and their instructions inside those functions will be executed. Let's run it one more time. I think this time I will be Jerry. What is my height? 6'3". Sounds good. My weight? I have no idea what a 6'3" individual would weigh. I'm going to guess 214 pounds. And let's say this is a 32-year-old. And we'll make them male. Again, notice this time I'm typing in lowercase m. Now, to be sure this is working as we expect, let's type in 5. And notice we don't have 5 as an option. It tells me it's an invalid entry. Jerry, try again. This time we'll say that we're very active. So Jerry, if he's very active, would need to eat 9.5 candy bars to maintain his weight of 214 pounds. Let's recap. The main should look cleaner and still follow our input, process, output strategy. We're relying on functions to manage all the details. C++ enforces a strategy of code small, single-purposed functions. They can only return one item. So in this case, there's no way for me to write an input function that returns the height, the weight, the age, and gender, unless they're organized into one unit, which they are not. They're all individual variables. So we're using individual functions to retrieve each one of them. The process takes inputs and produce outputs. And so we calculate the BMR, and then we adjust the BMR based on the activity level. Finally, calculating the candy bar count based on the BMR divided by the candy bar calories. And then our output section prints the BMR report. This strategy makes it easy to follow the code. It also makes it very easy to find and fix any trouble in the code. We can go directly into one of these functions and isolate it. If we had a problem with our calculation for BMR, it's isolated within the BMR calculate BMR function. If we had a problem with the activity adjustment, we can isolate that to the activity adjustment function and just make any changes as needed right here in the code without affecting the rest of the program. So I encourage you to try this at home, rewrite homework 2 in a set of functions, and let me know how it's going in the open forum. Happy C++ coding!